Question 8 is not a straight line graph question necessarily. It's about the gradient of a line and being able to interpret the gradient of a line. So the graph shows information about the distance travelled by a car for different amounts of petrol used. So familiarise yourself with the graph. This is the amount of petrol used in gallons. This is the distance that you get from that amount of fuel. Question A wants us to find the gradient of the straight line. Now the gradient is always calculated by the rise over the run. So that's the difference in the y-axis over the difference in the x-axis. In order to do this easily, my advice is to find 2 points where they cross over a major axis line. So that's the first one, 0, 0. And I'm going to look up here to where it crosses over quite a major point. And I've got one there, actually, which is 5, 200. So I'm using those 2 points. What I'm going to do is show the examiner that I know exactly what I'm doing, and I'm going to put a right angle triangle on these axis. And I'm going to show that I've got a rise of 0 to 200 and a run from 0 to 5. So a run of 5. So my gradient is going to be 200 divided by 5, which equals 40. Now part B wants us to put that into context. It wants us to write down an interpretation of this gradient. So what we did here is we divided the amount of miles that you can travel by the number of gallons of petrol used. And what you end up with is a rating called miles per gallon. So the 40 actually means that you get 40 miles distance from 1 gallon of petrol. And that's your interpretation. It's 3 marks altogether. For this you get 1 mark for showing that you've identified the correct triangle on the axes and doing a division. There are a range of answers for this, and they would accept anything from 35 to 41 as long as you've shown that you've done the change in y over the change in x. So your second mark is for getting an answer in that range, and then that's just a 1 marker for any correct interpretation of what the gradient actually shows. Question 9 is a perimeter question, but made slightly more complicated because they want us to use Pythagoras also. So the diagram shows the marking on a school playing field. The diagram shows a rectangle and its diagonals. Now the fact that they've told us it's a rectangle means that I should straight away realise that opposite sides are equal. So if that's 52, that's 52. If that's 39, that's 39. I'm going to write them on my diagram so I don't forget about them. So the rectangle and its diagonals. Work out the total length of the 4 sides and its diagonals. Now I don't have any length for the diagonals. This is where Pythagoras comes in, because this is a rectangle, so I know I've got a 90-degree angle down there. Now to find the length of the diagonal, hopefully I should be able to see that this is just a right angle triangle, and this is going to be exactly the same. Okay, so both of those lines are going to be the same. So the first thing I'm going to do is find the length of this, and I'm going to call it x. So my diagonal is x. So in order to find x squared, I need to do the sum of the 2 shorter sides squared. So x squared equals 39 squared plus 52 squared. Then I'm going to put that in the square root because I wanted to get rid of that root there. So in my calculator, I'm going to do the root of 39 squared plus 52 squared. You can, of course, work the squarings out first, add them together and then root them, but this is just a lot neater. So on my calculator, I'm going to say I want the root of 39 squared and 52 squared equals, and that's going to give me straight away 65. So that means that the diagonal is 65 meters long. Now I've got 2 diagonals, so I'm going to multiply that by 2, and that's going to give me 130 meters. So there's my 2 diagonals. Now I've got here my 52 and another 52 and my 39 and my other 39 and my 2 diagonals. And when I add all of those together, and even though it is adding, it's a calculator paper, so just in the interest of accuracy, use your calculator, and that will give you 312 meters. Now this is a 5-mark question. I think it's a lovely question. You get 1 mark for correctly showing that you needed to use Pythagoras to find the missing lengths of the diagonals. You get a 2nd mark for showing that you can find the 65 meters. You get an answer mark for that. You get a method mark then for adding them all together, and then you get the final answer mark for getting the 312. Question 10 is about, well, ratios and proportions. There's a lot of areas of maths involved in this question, and they've been particularly horrible, I think, by making it about packages and parcels, because they sound very similar, and so it's quite difficult to set it up in an algebraic way because they both start with P. However, bear with me through it. So Susie has to deliver some packages and some parcels. The total number of packages is 4 times the number of parcels. The total number of packages and parcels is 40. Now at this point, I'm going to stop because I've forgotten what I've read above. I don't know what the parcels are. I don't know what the packages are. So let me try and set it up as a ratio. So we're dealing with packages and parcels. So packages and parcels. And what do I know? Well, I know that the total number of packages is 4 times the number of parcels. So if I've got 1 parcel, I've got 4 times that in packages. So for every 1 parcel, I've got 4 packages. Now I've dealt with that piece of information. The total number of packages and parcels is 40. So packages and parcels have a total of 40. Each parcel, so that's just the parcels, each parcel has a weight of 1.5 kilograms. Now, before I can do anything with that, I need to know exactly how many of the items she had to deliver are parcels. So this is where ratio comes in. So I want to find out what 1 part of each of these is worth. So in order to find 1 part, I take the sum of the parts, so 4 plus 1, which is 5, and I share the total, which is 40, between those 5 parts, and 40 divided by 5 is going to give me 8. So that means 1 part is worth 8 of whatever I'm dealing with. So here I've got 1 lot of 8, and here I've got 4 lots of 8. So I can actually now state that I have 4 times 8, which is 32 packages, and 8 parcels. And do they add up to 40? Yes, they do. So I know I've got 32 packages and 8 parcels. Now I can move on to worry about the weights, because each parcel has a weight of 1.5 kilograms. So I'm dealing with a parcel. There's 8 of them, and so I've got 8 lots of 1.5 kilograms. That means my total parcel weight is 8 times 1.5, which is 12 kilograms. Great. So let's read on. The total weight of the packages and parcels is 37.6 kilograms. each of the packages has the same weight. Work out the weight of each package. So I know that each parcel weighs 1.5 kilograms, and altogether my parcels add up to 12 kilograms. Now I need to look at the packages. So what do I know? I know that the parcels and the packages add up to a total weight of 37.6 kilograms. And what I do know is that my parcels have a total weight of 12 kilograms. So my parcels are 12 kilograms plus the total weight of my packages is going to give me 37.6 kilograms. Now, in order to find the total weight of my packages, so my packages weight in total is going to be 37.6, take away that 12 kilograms which belongs to the parcels. So 37.6 take away 12 is going to leave me with 25.6. So that is the total weight of my packages. Now, I worked out up here that I actually had 32 packages. So I know 32 packages have a total weight of 25.6 kilograms. I can quite easily now find out what one package is worth by dividing both sides by 32. So 25.6 divided by 32 is going to give me 0.8 of a kilogram. So one package is 0.8 of a kilogram. This was a 4-mark question, and despite the question being so complicated, the mark scheme is actually quite simple. You get your first mark up here for correctly working out that you were going to have 8 parcels. And then from that, you could have done 8 parcels times by that gives you your second method mark, which is the fact that the parcels add up to 12 kilograms. Now, from this point on, you get follow-through marks. So the next mark is for showing that you've taken the total weight and you've subtracted whatever you've had here. So if you didn't get 12 kilograms there, as long as you've taken what you've stated to be your total weight of the parcels, subtracted from the total, that gets you that method mark, as long as you've then divided it by the 32. Okay, and again, if you didn't manage to get 32, but you've divided that incorrect answer by your incorrect answer, then you will get that method mark as a follow-through. From that point then, you get an A1 mark for getting the 0.8 kilograms correct. Question 11 is for using a table of values to plot a graph. Complete the table of values for y equals 2x squared minus 1. Now, this isn't going to be a straight line graph. I know it's not going to be a straight line graph because it's got a squared in it. Okay, it's a quadratic, it's not going to be straight line. A straight line graph would have no powers, it would just be a linear expression. Now, the fact that it's got a square in it means that they've set you up to make a mistake here, especially if you're heavily dependent on a calculator. The first thing that you need to be aware of is that this 2x squared is not 2 times by x and then you square it. That's what it's not. It's 2 times by your x value squared. Okay, so you have to square your x first before you multiply it by 2. So you've got to be quite careful when you're inputting this to a calculator. So complete the table of values for y equals 2x squared minus 1. I'm going to do the 0 first. I leave the negative 1 till the end. I'm going to do the 0. So here, I'm going to do, first of all, 0 squared, which is 0 times 0, which is 0. I'm then going to multiply it by the 2. 2 times 0 is 0. And then I'm going to subtract my 1, so that will give me -1. Now I'm going to do this one here. So first thing I do remember is I forget about that and I just do my x squared. So 2 squared is equal to 4. Now I need to multiply that 4 by the 2. So 4 times 2 is 8. Then I can subtract my 1 and that will give me 7. Now I'm going to do this negative value. So I'm going to do the x squared first. -1 times by -1. Well, you've got a negative and a negative, which will give me a positive, and 1 times 1 is 1. So I end up with 1 there, times by that 2, which will give me +2. Take away 1 would end up giving me a +1. Be careful when you're using a calculator, make sure you enter it like that. Okay, so 2 times by, and then the x squared in a bracket, close the bracket off, and then subtract 1. So I need to plot my table of values now. First point I'm going to plot is -2, 7. So -2 up 7. Then I'm going to do -1, 1, then 0, -1, then 1, 1, then 2, 7. And if you've plotted it correctly, you should have a nice curve there. You should have known, just by looking at this, the fact that it's got an x squared in it, you should have known it was going to look like that. Okay? Just as you should always know, if there's no powers, then it's going to be a straight line. Part C wants me to use the graph to write down estimates of the solutions of the equation 2x squared minus 1 equals 0. Now hopefully you will have noticed that this is exactly the same as our question was above. The only difference is above they had it written, if I put it down here, as y equals 2x squared minus 1. Now think about this logically. If y is equal to 2x squared minus 1 and 2x squared minus 1 is equal to 0, then because they're the same thing, that must mean that y is equal to 0. So what I need to do on my graph is find the point where y is equal to 0, and that actually represents a line, and it's the line that is the x-axis. So the solution is going to be where your curve crosses the x-axis. So this is the first cross. That's the second cross. Now, you will get follow-through marks here, and there is a range of answers because everyone's will cross through in a slightly different place. Mine crosses through the negative axis at 1, 2, 3, 4, 5, 6, 7, 8. Negative 0.8 and 5, 6, 7, 8. Positive 0.8. So my solutions are negative 0.8 and positive 0.8. You can accept anything in the region from 0.6 to 0.8 and negative 0.6 to negative 0.8. So with regards to how the marks are allocated here, the table was a 2-mark question. You get both marks for getting it fully correct, or 1 mark if you only got 1 or 2 of them right. So if you only got 1 of them right, you still get a mark. Then down here you get 1 mark for at least 4 points plotted from your table. But all points have to be within 1 square of accuracy. So you would get the follow-through marks there to get 1 mark. In order to get the second mark, though, you do need to have the curve exactly correct. For then part C, you get 1 mark for correctly identifying that the solutions are going to be on the x-axis, and you get the second marks then for it being an A1 and getting the values actually correct. Question 12 is a combination of distance, speed, time and standard form. So an object is travelling at a speed of 2,650 metres per second. How many seconds will the object take to travel a distance of 3.45 times 10 to the 10 metres? Give your answer in standard form, correct the 2 significant figures. lots of information here, and they're very specific about how they want the answer to look. So what have we been given? An object is travelling at a speed. So first thing I'm going to do is write my speed out, which is 2650 meters per second. How many seconds will the object take? So time is what they want to know, and they've given me the distance, which is 3.45 times by 10 to the power of 10. Give your answer in standard form, so I'll deal with that at the end. So I want to find time. Now I know that time is equal to distance over speed. So my distance is 3.45 times 10 to the 10 divided by my speed, which is 2650. Now this is a calculator paper, so you can just enter the standard form on the calculator. So I've got 3.45, and then I'm going to press the standard form button, which is this one here. And on the display it says times 10. Now because it's to the power of 10, I just need to type in the 10 there. So that's 3.45 times 10 to the power of 10. And I want that divided by 2650 equals, and I'm going to write all of the numbers on that display down first. So that's 1301886.92. So by writing it all down means I've secured at least one of my marks. Now I need to round it to two significant figures and put it into standard form. So that's the first significant figure, that's the second. So after that 3, I don't want anything other than zeros. So the one directly after my cutoff point is a 0, which means it doesn't round up. So that's going to be 1, 3, and then all of these other values become 0. So there's my answer, rounded to two significant figures. Now I want it in standard form, so it has to be a number between 1 and 10. So that has to be 1.3 times by 10 to the power of. Now, in order to decide what the power is going to be, I need to start at the end and count how many spaces back I've moved. 1, 2, 3, 4, 5, 6, 7. So it's 7 spaces, and because my number was very large, it's positive 7. So the answer is 1.3 times 10 to the 7. It's a 3-mark question. You get 1 mark for showing that you know how to find time, and it's dividing distance by speed. You get 1 mark for getting that calculation answer correct, and then you get the final mark for having the answer written in standard form. 13 is a direct proportion question. So it says y is directly proportional to x when x is 600 and y equals 10. Find a formula for y in terms of x. So first you need to be aware of the notation that we use. We can write y is directly proportional to x as y and then that sign x. Now what that sign means is y is equal to k times by x. So it's a constant number. We don't know what that is at the moment. It's just a constant. So now I've got y is equal to kx. I can sub in the values that they've given me here. So they've told me that y is 10. So I got 10 equals. K is the constant. I don't know that. Times by x, which is 600. Now I need to solve that for k. So I need to divide by 600 on both sides. So it cancels down there, leaving me with k equals, and you can either have 1 over 60 or 0.016 with a recurring dot above the 6, but I'd advise you keep it as a fraction. That's what they've done in the mark scheme. So now I know what k is, I can rewrite my formula with k in it, but with x and y as variables. So y is equal to 1/60th of x. And that is a 3-mark question. So you get 1 mark for correctly writing the statement out in terms of y and x. So y equals kx. You then get the second mark here for showing that you can substitute the values of x and y into the formula and solve for k. And then you get the final mark here for putting it all together. Part B is a 1 marker and it uses your answer from above. It says calculate the value of y when x is 540. So this is just a straightforward substitution question. Now from above we know that y is equal to 1/60th of x. So if x is 540, y would be 1/60 multiplied by 540. Now, if I've got 1/60 set in my calculator, that's great. If I haven't, then I can just put in 1 divided by 60 equals. So I've got 1/60th back on my calculator. Then I just press times by and type in 540 equals 9. So y is equal to 9. It's only a 1 mark question, so it's either right or wrong.